few weeks ago, I started a blog series about Databricks performance in ETL, and we used a modified version of the TPC-DI benchmark. The initial entry in the series focused on how Databricks has improved its own performance over the last 3 years, and also just a little bit of facts about the benchmark itself. The additional entries in this series are designed to focus on how Databricks performs against other cloud data platforms and if there's any other insights we can gather from it. The first entry in the blog series was focused on Snowflake. Now, most in the data analytics community had very positive feedback to the blog entry. However, those in the Snowflake community had a general disagreement with the results and the conclusions drawn from the blog entry. As you can see here, there were a number of very negative reactions in social media. This is only a handful of the responses since we had to delete some and some were deleted by the original poster. So we're going to do 3 things in this video. The first thing we want to do is determine if there's any validity to the claims that we didn't test Snowflake fairly. The second thing we'll do is we're going to retest. We'll take the main suggestions we received, including the smaller files, the parquet files, making sure that we're getting the files split correctly. We'll take all of those and see if there's any validity when we do a retest. All of our retests, at least the final test we do of each iteration, is recorded so you can validate our results. And provided we have enough time at the end without making this video too incredibly long, we'll do some deeper analysis and take a look at what this experience was like testing both platforms. So before we move any further, I do want to make sure to get a chance to thank one of my colleagues out of Canada in SSA named Retta, who was very helpful in getting our DBT code debugged and set up our trials in Snowflake, make sure a lot of the initial tests were done. The tests you see here on the screen are the final versions that we actually recorded to make sure we had it ready for video. But if it wasn't for his help in getting a lot of this set up initially, this video wouldn't have been possible. So just want to make sure to thank Retta and also move on now to showing exactly why Snowflake thought that we got our initial test results incorrect. We had a segment that talked about the challenges we had testing Snowflake because we weren't able to get Snowflake to get parallel reads on the original large files. Now, Snowflake 2XL warehouse is 64 nodes. That's 256 total cores. And what you want is for each core to not sit idly. Large files are not what makes a warehouse go slow. It's the idle cores that aren't doing any work that makes it go slow. And so when we took the 1 terabyte data set and split those files up to ensure no files were over 1 gigabyte, we ended up with hundreds of files for the warehouse to still read. And you may have seen earlier about how many times we were pressured to use the multi-line equals false command in the read. We did try it. It didn't affect anything. And the result was a negligible change in performance. We still weren't getting the files to read in parallel. But that didn't stop everyone from continuing to push and tell us to try this, despite the fact we were telling everyone we did.
You keep using that word. I don't think it means what you think it means.
So in the backdrop of the negativity stemming from the Snowflake community about this blog, it was actually quite refreshing to work directly with product teams at Snowflake to ensure that our benchmark results were correct and to actually fix any of the code if there were issues. And so as you can see here from our message history on LinkedIn, James Malone, a former Snowflake product manager, was able to make a warm introduction over to a product manager at Snowflake. And we worked behind the scenes and we met during Data and AI Summit 2 weeks ago to make sure that the test that we had in place was accurate, the code we had was accurate, and it took a couple of days to flesh out what the issues were. So using multi-line equals false wasn't the only thing we had to address. It turns out that what we also had to add on was to ensure that the set compression equals none on the files were also set, which was a little odd because we were using compression equals auto, which seems like it should be a little bit more automatic in this case, but nonetheless, we changed that and it still didn't work, as you can see here from the message history. So after another day or two of looking at the code, the product team at Snowflake was able to find the root cause of the issue, and it's something that wasn't documented about ensuring that you're not reading directly from external stage. So in this case, what we were doing in the original test was essentially creating an external stage or external table in this case. It's kind of like having a view on top of the raw files in stage. All right. So the advice was don't read from an external view or these tables. Instead, take that middle layer out and just read directly from the source files themselves. So upcoming, you're going to see 2 tests primarily. First is the original test as it was conceived in the benchmark with the original pipe delimited text files. The second thing we're going to do is to follow the advice we've seen from the Snowflake enthusiast and actually split the files up where we have about 200 megabytes on average parquet files that we're processing here, and we're actually going to process them as parquet. So we have two primary tests, the original pipe delimited text, parquet that's been split up into 200 megabyte chunks. Okay, without further delay, let's begin with Snowflake Gen 1 on the original files. Kicking things off with CSV and with Gen 1 warehouse on Snowflake. As you can see, this is just code in the IDE and where we're going to launch our DBT code. You see all the different SQL files that are actually located in the Snowflake _CSV directory within our repo. On the right side of the screen, you see the external stage location with all of the actual files we'll be reading, which most of these will actually be pipe delimited text files. Now this video, we will fast forward large segments to make it easier to consume and make sure that we do not have video that's over an hour long. So first we're going to clean up our schema here, make sure that all the tables are dropped. We're going to do that before every single run we do in all the tests. Before every run we will refresh just to make sure the correct file formats are in place. So after executing a DBT run, our DBT job kicks off. On the right side, we have a query history page that will automatically refresh. And on the left, you could see the DBT job completing in the IDE. We're working against the Gen 1 2XL here to start with. We'll jump back over to our query history screen while we wait for this job to complete. For the sake of everyone's time and sanity, we'll just speed this up, fast forward by 100x until we get this job completed. Okay, our job is complete. Took about 15 minutes, costing almost $25. After each run we show here in this video, we'll run a couple of scripts. First to check to make sure our row counts match expected row counts, and then we'll just run a couple of sample queries that I created to show how performant a BI-like or ad hoc type query would be on the data we just loaded. We'll initially begin with a BI-like query. We're working against an extra small Gen 2 warehouse. This is the smallest warehouse you can get in Snowflake. It's $4.05 an hour for a Gen 2. And as you can see, we're running about 9 seconds cold, and we typically end up about 5.4 seconds or so on a warm run. So the second run is the ad hoc query, which is just trying to pull back a single row. And this one, it runs in about 18 seconds when it's cold. And then now when we run it as a warm query, it's going to run in about 15 seconds. Moving our attention to Gen 2, as you can see, we're going back through our drop table commands to clean up our schema. Followed by that, we are going to rerun our file formats again as a sanity check. And next, we're going to execute our DBT run again, which will kick off our job. On the right side, we'll have a query history page running. On the left, the DBT run is executing inside of our IDE. And as you can see on the right side, we're executing these against the Gen 2 2XL warehouse in Snowflake. And our Gen 2 run is complete. The DBT side will update momentarily, but all the queries are done. Took about 10 minutes, $21.50. We're going to check our row counts to make sure everything matches, and they do here. And now let's jump over to a couple of sample queries. We're doing them in reverse orders last time. We're going to start with an ad hoc query. In this case, we're again running on an extra small Gen 2 warehouse, which is the smallest warehouse Snowflake offers, which is $4.05. And it takes about 20 seconds for a cold run and 17 seconds for a warm run here. Moving over to our BI-like query, just like last time, it should be pretty similar results as last time. And we have an 11-second cold run, followed by a 5-second warm run. Okay, Snowflake test complete, operating against the original pipe delimited text files. What we're seeing here is that even though you're not splitting the file, we got better performance than the split version from the original blog. All right, so here what we're noticing is that it takes Gen 1 about 50% longer to execute the pipeline than it does Gen 2. And at the same time, because it's bigger than that 35% cost increase, it's actually cheaper to run it with Gen 2 overall, leading to a 10% higher cost for Gen 1 to run this pipeline. So it's 10% more expensive, 50% longer to run. How does this compare to the original blog results? Well, Gen 2 on the original blog was 20% higher in total cost, whereas Gen 1 was 40% higher. So it's a gap, especially for Gen 1, but it's not a huge gap. And so what we'll notice here in a bit is that because Databricks also announced improvements at Data and AI Summit, we're going to see, does that actually even change the narrative at all? So let's go and take a look at what we announced at Data and AI Summit.
And we have big news. We're excited to announce a next-gen version of the data warehouse. This next-gen version of the data warehouse is 29% better in performance, but we're also increasing the price by 35%, okay? Just joking. This was last week, okay? We have to have some fun. All right, so here's what we're actually doing. We improved the performance by 25%, and we didn't change the price at all. So it's just released now, and it's available in DB-SQL everywhere today.
So I think that Ali, like many CEOs, are a little overzealous in their keynotes. So I just want to make sure everyone's aware that we were beginning to roll out our new generation of DB-SQL warehouses as of the week of Data and AI Summit, but that is a multi-stage process and probably will continue through the beginning of July. So if you are testing some of the things we test later in this video and you don't get exactly the same results, it could be that you're also not quite yet at that new generation of warehouses. But let's take a look and see what the Databricks results were. Just like we did in Snowflake, we're actually going to drop all the tables in the schema to ensure that everything's cleaned up. And now we can see that there are 0 tables in our schema. Now, if you'll notice, we're pointing to the model path at Databricks_CSV. In this location, you have 3 folders executing our DBT run here on the left. And on the right, you see query history as these jobs are coming in. We're going to speed the job up so that we don't need to wait for the whole execution of the job. But in the end, you see that we finished at about 3.7 minutes. And $6.22 in total cost. Now moving forward to confirm our matching row counts. After running our script, we see that every table has a matching row count to what is expected. Okay, so now let's chart the results of the Databricks SQL run compared to Snowflake. And at this point, it looks pretty similar to the results we received in the output of the first blog. The change in code did help improve performance as we saw on the last chart for Snowflake, but with Databricks' new generation of Databricks SQL warehouses, we also see an uplift on the performance there. So, which means the end result is that it's basically a wash. So you're seeing 2.8 and 4.3x longer to process in Gen 2 and Gen 1 respectively. And then it's now 3.6 or 4.1x more expensive to process on those platforms as well. So one thing we found interesting was the amount of feedback that we should have been testing using Parquet, that for some reason text files or CSVs are not the typical norm.
It's a bold strategy, Cotton. Let's see if it pays off for them.
Bold strategy indeed, but who am I to turn down a good time? So what we'll do is take every file we need to ingest and we will turn it into a Parquet file. And then anything that's bigger than a couple of 100 megabytes, we will split those files up and make sure that we have roughly 200 megabyte files to ingest for every single file. And this was the other common refrain we heard from the Snowflake feedback. Let's get on to the Parquet test. So for the Parquet run, you'll see that we're going to speed this one up a considerable amount. If you want to pause and see what's going on, do feel free to do so at any point. But as you can see, we're pointing to the Snowflake_Parquet location here. And the main difference is that our file format has changed. So we'll go ahead and confirm accurate file formats as a sanity check here. And we'll also make sure that our schema is cleaned up by dropping all our tables. So on the left here, we're running the DBT job, and on the right, you'll be able to see our query history page. We're going to speed this up considerably, and we're also only showing Gen 1 actually running to completion, and then we're actually just going to show Gen 2's output at the completion, so you know exactly how long it took from both the DBT side and from the query history side. Here, what you're seeing is this one's coming to a completion, and it finishes at just under 15 minutes for the Gen 1 side. The Gen 2 results actually show that it's just over 10 minutes to complete. So again, this still falls very much in line with our CSV results. 2371 for Gen 1, 2225 for Gen 2. Let's check to make sure that our row counts match, and then we're going to jump into our queries. Now again, this portion here where we're doing the BI-like queries and the ad hoc queries, it's just to test something that we're going to show in Databricks here in a moment. But in the end, these results should actually be the same on the left and the right. There's been no optimization done on the right or after. These are just the same queries against the data twice. Once that was loaded from Gen 1, once loaded from Gen 2. All right, taking a quick peek at the results. I'm not going to spend a lot of time on these results because, believe it or not, they are the exact same results as what we got with CSV. It's 50% longer to execute for Gen 1 and 10% more expensive. The performance and cost were almost exactly the same as they were in CSV. So let's see how it compares against Databricks. So let's go ahead and kick off our DB-SQL version of the Parquet job as well. Here we are running against the same 2XL serverless warehouse that we were running against earlier. And on the right, you'll see we have a volume, and then on the left is our DBT job. First, we're going to clean up our schema here, make sure that everything's cleaned out, and then on the left, we'll launch our DBT run. But on the right, we have query history coming up. So we've sped the video up so much that you can't really tell exactly what we're doing here on the right side. While it was running, I was just opening some query profiles to take a look. But nonetheless, the job is already finished because it finished in a blazing fast 2.7 minutes for $4.50.
Huh.
Now we'll just check to make sure that our row counts are matching what we expect, and this job is complete. So despite recent improvements by Snowflake, especially with Gen 2 on reading Parquet, it's pretty obvious they are still woefully behind in ingesting Parquet compared to Databricks. The CSV tests were much closer, but now you're seeing a gap of 5.2x more for Gen 1 and 3.5 for Gen 2. And despite Gen 2 being a more expensive warehouse than Databricks SQL is using, at this point, it's now approaching 5x in terms of cost as well. I mean, this is worse than the original blog. I mean, all the noise for this. I mean, not everyone was in an uproar about this, but there were so many toxic responses and so many posts that I had to delete. I had to block someone from even posting because of the level of his responses. I mean, it's the same person here that thinks it was a fantasy that anyone would ever promote the fact that we're 5 times cheaper. I had other posters suggesting that I retest and apologize. No, seriously, this guy really wanted me to apologize. And it's like I said, not everyone was in quite the uproar, not everyone was so toxic, but it's always the minority, it seems, that causes this deafening noise that makes it so that users and practitioners and people like myself, customers, they learn to hate benchmarks, which is actually a topic that I really want to explore, I think, in my next blog. Now, of course, this is just one benchmark. I even described that in the original blog entry when we talked about just Databricks performance in this benchmark historically over the last 3 years. However, it's more of a heuristic most customers can take. Now, before we wrap up this video, I do want to show 2 more things. The first is a clustering test. What happens if you actually cluster this data? And the reason why I want to show you this is because it really hits home how much of an advantage Databricks has on this benchmark. Databricks and Snowflake both have a capability for clustering. I don't want to mislead anyone before Snowflake complains that they also have clustering as well. But what I want to show in this test is the fact that Databricks has such an advantage in its ETL performance that it can actually still cluster the data and still be consistently 3x or more cheaper than Snowflake, while also getting the data optimized at the same time. So no need for a background optimization job or anything to keep your performance fast on a serving layer. So let's take a look at this job. So very similar to what we had earlier, query history on the right, we'll do DBT job on the left inside the IDE. And you'll notice that as this is running, I actually purposefully go through every single SQL file with the intent to just show that we are clustering by every single one of our fact tables, even though the queries we're going to use in a moment will only actually hit 2 of these fact tables. We're going to speed this up 32x to get this done quickly and wrap this video up. If you want to pause to take a look at anything we're operating on here while it's running, feel free to do so. If you have any questions, let us know. But as you can see, the job finishes at about 4.5 minutes, which is about 21% longer than the CSV job we were operating on earlier. But with that extra 21%, we were able to cluster the vast majority of the data here since all of the fact tables got clustered. So after a quick validation that our row count matches what's expected, let's turn our attention to some ad hoc and BI-like queries. First thing we'll do is we'll validate that this back market history table, which is part of our ad hoc query, is the exact same table we just wrote and which columns that it's clustered by. Once that's completed, we can go ahead and start our query. Here we're running it against a 2 extra small Databricks SQL warehouse. In this case, it's $2.80, which is actually a fraction of how much the smallest warehouse for Gen 2 is on Snowflake. And here you'll notice that we run this twice. Again, we get a cold run, we get a warm run, and our results here show that we get about a 0.4 second query result. And lastly, shifting our attention to the BI-like sample query. What we're doing here is just hitting dim trade. We'll open up dim trade, let you see that we're using the exact same table we just loaded. with the two columns that we're clustering by, and then we'll circle back to our BI-like query. In this case, we're just joining to several different dimension and reference tables, which force the query to have to hit the dim trade table via dynamic filters. And our BI-like query comes in at just over 3 seconds. Okay, with that job complete, let's take a look at the metrics, and we'll analyze the metrics slightly different in this case than we did on the last couple of cases, because here Databricks SQL ran a test that Snowflake did not run. We ran a test on Databricks to show just how wide the gap is, that we can actually optimize the data, get all of the data clustered, and then make your queries performant for serving downstream all at the same time, and still do so for 3 times cheaper than it would cost just to get the data into Snowflake. Many of you are probably asking the same question. What does this all mean? So the test we just ran reflects that Databricks is still over 3 times faster and cheaper than running the same job in Snowflake, even while keeping the data optimized and clustered. At the same time, because that data is optimized and clustered, it's up to 6 times faster in query performance. It's also not my intention to mislead anyone, because Snowflake can also optimize and cluster the data as well. In the end, it's not a free task, and as you can see here, the performance can get better on SQL queries, and so maybe you won't have that 6x performance difference here, but at the same time, that will lower your performance in ETL. And so now that gap will grow to over 5x again. The key area of focus in this test was to really drive home how big of a gap we've been talking about so far between Databricks and Snowflake in this benchmark. 5x is a big number. It's so big that whenever you throw in the optimizations, you throw in the clustering, it's still 3 times more expensive to get the job done in Snowflake, even without doing all of those things. One could argue that we actually gave Snowflake as even a level playing field as we could for this benchmark, because the elephant in the room is that most customers don't run ETL jobs on a Databricks SQL warehouse. They run jobs against a Databricks cluster. They run workflows. I can take the same job and run it against a Databricks SQL warehouse, and I can run it against a Databricks cluster. And when I run it against a Databricks cluster, the price actually goes down even more. So as you can see on the screen, this is the output of a workflow in which I ran the same exact job, this time with a cluster. And instead of running it with 32 workers like Snowflake does in their 2XL warehouses, I ran this with 20 workers. And even including the cluster startup time, it still finishes faster than Snowflake can execute this job. So this job run that you see on the screen, including the cluster startup, including the infrastructure charges, and that includes EBS volumes, that includes the compute cost, including the Databricks DBU cost, all of this combined still net a total of about $4, making this up to 7 times cheaper than running the same job in Snowflake. So this video is already over 20 minutes at this point. I had more I wanted to talk about from a macro analysis perspective, what this experience was like. But I think that we've already put together a good story here. I think that anyone watching this has already got a good idea about how Databricks and Snowflake compete in this benchmark. Again, it's just one benchmark. Snowflake has plenty of things they still do well. I never believed that this was something they would push back so hard on. I didn't think this was the hill they were going to die on, if you will. But at the same time, I look forward to hopefully having the kind of response to these types of benchmarks that's a little bit more in line with the behind the scenes backroom discussions with the Snowflake product team to make sure that we got it right. I have more in this series I hope to come out with, and in the future, whether that's BigQuery or Redshift, if it's EMR or Dataproc, whoever we're competing against, please just reach out to me directly. If there's an issue with what our tests are producing, if there's a problem you have with the test, just let us know. There's no reason to attack it out in public and bring all this toxicity. At the end of the day, we're all in the same community. We could all end up being co-workers at some point. What we don't want is to have all this animosity and toxicity in the community whenever we could be co-workers and need to actually coexist in the future, right? So either way, thanks for all the support. I do appreciate everyone who actually had a chance to read the blog and reach out. Hopefully this video makes its mark. Thanks, Retta, for helping with the benchmark, and I look forward to getting the next entry into the series out soon. Thanks.